Section 2.6, proving angles congruent. The first thing we come across is the vertical angle theorem, or VAT, or VAT. This states that vertical angles are congruent. Well, this is something we already knew, but the reason we're putting this formally in words is now we're going to be using it in proofs. And this is a very important one. We use it a lot. Here we want to use the vertical angle theorem to help us prove or solve for a value of x. Well, I know that these two angles are vertical angles, so they should be congruent. So naturally, I'm going to set them equal to one another to solve for x. In this case, I'll subtract 4x from both sides of my equation. I get x minus 2 equals 17. And then I'm going to, in this case, add 2 to both sides. And you get x equals 19. Now that I know what x is, I could just plug it back into both expressions. And doing so, I get that the angle on the left is 93 degrees. And then when I add it into the angle on the right, we get 93 degrees as well. Here we want to solve a proof using the vertical angle theorem. In this problem, the first thing they give us is angle 1 is congruent to angle 4. And they want us to prove that angle 2 is congruent to angle 3. So that's going to be our last step. So for this proof, I know my first step is going to be angle 1 is congruent to angle 4. And I know that my last step, or the thing I'm proving, is angle 2 is congruent to angle 3. Now I've got to figure out how to get there. Well, I know step 1, the reason behind that is the given. They provided that to us. So I know 1 and 4 are congruent. I know that I'm going to use the vertical angle theorem, so let's just pick out a pair of vertical angles. Let's say I know 2 and 4 are congruent because they're vertical angles. So I'll say 2 is congruent to angle 4 by the vertical angle theorem. Well, here's something funny. If 1 and 2 are both congruent to angle 4, doesn't that mean 1 and 2 are congruent by the transitive property? Well, let's use that. So angle 1 must be congruent to angle 2 by the transitive property. All right, so now I'm 1 and 2. I'm not quite at 2 and 3 yet, but let's see if we can find vertical angles maybe using 1 and 3 this time. Well, 1 and 3 are vertical angles, so I'll say that they're congruent. Angle 1 is congruent to angle 3, by VAT, or vertical angle theorem. Well, I should notice here that 2 and 3 are both congruent to angle 1. So if they're both congruent to angle 1, then they must be congruent through the transitive property. So we're able to prove that 2 is congruent to 3 through the transitive property at the very end using 5 steps in our proof. Let's try another proof. This time we're given that angle 1 and 2 are congruent, but this time we're trying to prove that angle 1 is congruent to everybody. Well, we start off the proof here with angle 1 is congruent to angle 2, which is our given step. From there, let's just start picking out a vertical angle pair, 2 and 4. So angle 2 is congruent to angle 4. And I know that because they're vertical angles, or vertical angle theorem. Well, once again, I look and I notice both 1 and 4 are congruent to angle 2. So that means they're congruent to each other through the transitive property. So angle 1 is congruent to angle 4 through the transitive property. From there, I still need to show that, well, if you look carefully, I've proven that angle 1 is congruent to angle 2. I've proven that angle 1 is congruent to angle 4, but I need to figure out a way to show 1 is congruent to angle 3. Well, 1 and 3 are vertical angles. So I'm going to go angle 1 congruent to angle 3, and this is by the vertical angle theorem. Now I've managed to show that angle 1 is congruent to all of the other angles. Well, if angle 1 is congruent to everybody, then everybody must be congruent. So my last step is just going to be my proof statement. Angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. And we're going to go ahead and say this is a really big transitive property. Theorem 2.2, congruent supplements theorem. If two angles are supplements of the same angle, so that means if two angles are supplementary to the same angle, or congruent angles, then those two angles must be congruent. So in this case, angle 1 and angle 3, when added to angle 2, both make 180. So that means 1 and 3 must be the same measure because angle 2 is not changing its measure. So if two angles are supplementary to the same angle, then those two angles must be congruent. Theorem 2.3, congruent complements theorem. If two angles are complements of the same angle or congruent angles, then the two angles are congruent. So in this case, they're saying 1 and 3 are complements and 2 and 3 are complements. Therefore, angle 1 and 2 must be congruent. I'm aware the diagram doesn't look to scale, but understand that it's kind of like the transitive property. We've got 1 and 3 and then 2 and 3. So 1 and 2 have 3 in common in terms of their complements, so they must be congruent to each other. Theorem 2.4, all right angles are congruent. Well, all right angles are 90 degrees, so they would naturally be congruent to one another. Theorem 2.5, if two angles are congruent and supplementary, then each is a right angle. So if two angles are congruent and supplementary, meaning they are the same measure and they add up to 180, the only option for them to be would be 90 degrees. So that makes sense. All right, here we're asked, or we're given that angle 1 and 2 are complementary, and 2 and 3 are complementary. And they want us to prove that angle 1 is congruent to angle 3. And so we're going to try proving this without the congruence complement. All right, so we're going to try doing this without the congruent complement theorem. And so we could just go, oh, well, we know the answer, it's a one-step proof, but this, we're going to make this a five-step proof. Okay, so the first step, we've got 1 and 2 are complementary. And we also know that 2 and angle 3 are complementary. And that's our given. If you think about what complementary means, we know that the measure of angle 1 plus the measure of angle 2 equals 90. And the same is true for the measure of angle 2 plus the measure of angle 3 equals 90. And we know this by the definition of complementary. Well, if you think about it, if they're both equal to 90, we can set them equal to each other because we're going to substitute this bottom part in for 90 here. So that means we're going to get the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And this is done through substitution. If we were going to solve this algebraically, we would subtract things to solve. So let's say we subtract angle 2 from both sides. Well, that leaves us with the measure of angle 1 equals the measure of angle 3. And we got here because we subtracted angle 2 from both sides. So we'll say the subtraction property. And then the last step here, since we know they have equal measures, we can say that angle 1 is congruent to angle 3, so that way we match our proof statement. And we know that angle 1 and 3 are congruent because the definition of congruence, which states that if they have the same measure, they're congruent. All right, here we want to use the diagram at the right to complete the proof that the measure of angle ACD is 130 by filling in the missing steps. So they start this problem by saying that angle ACB and BC, and ignore the L here, that's a typo. I don't know why it prints like that. ACB plus BCE is 180. Well, they didn't actually give us anything in this problem, so there's no given. We just know that ACB, and B is here, and BCE is 180 because this is the definition of a linear pair. It's a linear pair. All right? They are adjacent and supplementary, and they form a straight angle, so that's a linear pair. From there, we then plug in what each of those angles is equal to, or the expressions that they represent. So this is substitution. From there, they begin combining like terms. Then the 40 gets moved through subtraction. And then we divide by 14, so the division property, we get x equals 10. From there, we take what x equals and we substitute it back into the expression for angle BCE. And we get 130. Then we mention that BCE and ACD are congruent, and we know that because these two angles here and here are vertical angles, so VAT. And then therefore, ACD must also be equal to 130 because we substitute the 130 in for the BCE that we know is 130, so that is the substitution property. Here we want to complete the two-column proof. We're given that angle 1 and 2 are congruent, and the measure of angle 1 is 130. So in this case, we have a given, so our first step is given. Clearly the same as thing written there. We want to prove that angle 3, the measure of angle 3 is 130, so we've got some work to do. Well, in the next step, they tell us the measure of angle 2 equals 130. What they've done is, if angle 1 is 130, they've substituted it in, so that way angle 2 equals 130, because we know they're congruent. So we'll just say substitution. You could also say definition of congruence here. From there, they tell us the measure of angle 2 and 3 are equal. Well, we know that because they are vertical angles. 2 and 3 are vertical angles, so VAT. And then what they've done in the very last step is they take what angle 2 equals, and they sub it in for angle 2, and then they tell us that angle 3 must equal 130 through substitution. If angle A is 12 less than 3 times its supplement, B, find the measure of angle A and find the measure of angle B. Well, the measure of angle A, think about it, is 3 times its supplement. Let's say that's 3x, but 12 less than that, so 3x minus 12. For the angle B, which is the supplement, we'll just let be x. So these are our two angles. If they're talking about supplements, we're dealing with supplementary angles. So that means we're going to set the two expressions, or angle A plus the measure of angle B, equal to 180, because to be supplementary means to be equal to 180. So now we substitute in what we know. So we've got 3x minus 12 plus x equals 180. Combine like terms, that's 4x minus 12 equals 180. We'll add 12 to both sides. We get 4x equals 192. Divide by 4, and x should be 48. From there, we're going to substitute the 48 back into the expression for x, and we should get the measure of angle A to be 132, and then the measure of angle B is just going to be 48.